Good evening, my name is Caitlin Green, and this is going to be my vlog over the Chapter 8 textbook problems. As you can see here, we have a blank copy of the document. However, I will be reading and explaining my thought process from the copy that I have printed out and worked on, and if anything is obviously missing, you'll be able to see it completely whenever I submit the Word document as well. So let's go ahead and get started. On number 1, it says, in a drug study, 24 patients who have chronic headaches are randomly and equally assigned to 2 treatments. You have the new drug, which is supposed to prevent headaches, and then the control group, or the no drug. The patients record the number of the headaches that they have over a 90-day period. Given that this data below, follow the 6-step inference procedure or our 7-step hypothesis procedure to perform a one-tailed test with alpha of 0.05 for a hypothesis of HO, or the null hypothesis, equals mu E, which is greater than mu C, which I hope I'm saying that right. So as you can see our data here below, so from the question, we know that it's going to be a T for 2 test, and we know that we have 24 patients total for 12 in each group, and we know that we have to find the mean as well as the standard deviation for the T for 2 equation that we're going to be using later. So the calculated mean for group E is 13.83. And the calculated mean for the control group, that's a question in its own, but the control group had a mean of 15.91. I found the standard deviation as well. For E was 2.588 and C was 2.644. So the T for 2 equation is going to look something like T equals x bar 1 minus x bar 2 divided by the standard deviation of x bar 1 minus x bar 2. So the equation, because you have to do more, the equation for the standard deviation of x bar 1 and 2 for the denominator of the equation is going to be the square root of 2.588 squared plus 2.644 squared divided by 12, which is the total number of patients in each group. And we get a standard x bar of 1.068. So to finish off our T for 2 equations so we can find T calculated, we're going to get 13.83 minus 15.92 divided by 1.068 to get a T of a negative 1.95. So now we pretty much have all of our information together to go and set up our 7-step hypothesis. The author of this equation was, or I guess author of this question, excuse me, was nice enough to go ahead and give us the null hypothesis. So from it we made a alternative hypothesis of mu E is less than mu C. Alpha we know is 0.05, and T cal is negative 1.95, as we found before. And to find T critical, we're just going to go to table A as an apple to go and find the correct T critical value, and we get 1.72. And it's important to make sure that we always get the critical, I believe it's, no, absolute, excuse me, it's the absolute value of T cal. And so from that, we know that T cal is greater than T crit. So we are going to reject the null hypothesis and accept H1. And what that just basically means in English is that the drug did in fact significantly lower the average number of headaches compared to control group, which we can kind of see in the fact that the mean is lower in the experimental group than it is in the mean number of headaches in the control group, but obviously it's not enough information just to form an assumption. Going on to number 2, it says a critic immediately raises the possibility of a placebo effect in a new drug study. She substitutes the placebo for the drug and repeats the study with exactly 24 new subjects. Test the same hypothesis as in problem 1. So the setup is pretty much all the same, except of course, we do have different numbers, so we had to recalculate the mean for E and C, which for the experimental group it was 13.67, and for the control group it was 16.08. And then we had to find the standard deviation as well, which was 2.77 for this control group, and then 2.94 for, had it backwards, 2.77 for the experimental group, and then 2.94 for the control group, and N is still the same number. We also had to find a new T-cal, of course, because it's different numbers, and as it was the same setup as before, we had to find the standard deviation of x bar 1 minus x bar 2, which I got 1.17 for that value. So I took 13.67 minus 16.08 divided by 1.17 to get a t-calculated value of a negative 2.06. And so now all we have to do is just set up our hypothesis procedure. It's the same null hypothesis and alternative hypothesis as before. Our alpha is still 0.05. Our t-cal value is the absolute value of a negative 2.06. And our t-critical value is still the same at 1.72. So once again, we will reject HO and accept H1. And what this means is that the average number of headaches in Group E was once again significantly lower than Group C. So that must mean that something is obviously right with this drug, as in that it is continuously lowering the number of headaches that the experimental group is having in comparison to the control group. Moving on to question 3, it just asks us to briefly consider the two studies and what would we conclude. Well, with the data present, it does appear that the E group appears to be effective, or the medication for Group E appears to be effective in reducing the average number of headaches in comparison to the control group, which had obviously none, or no medication, excuse me. Okay, going on to number 4. It says a student executes a computer program to output 50 random observations from a normal population with a mu of 10 and a sigma of 2. The x-bar of the 50 scores is 10.75. Should the students expect something at the computer program? Which just basically means is they giving correct data or is something off? And so this will be a two-tailed test because they don't, say is it giving too much values or is it giving values that are too less. So we have to test both ways. We know that n is 50 and the mu is 10. Sigma is 2 and x bar is 9.73, which we're going to be doing a z-test here. So that'll be x bar 1 minus x bar 2 divided by the sigma of x bar 1 and x bar 2. And to find that value, I took the square root of sigma squared over n1 plus sigma squared over n2. And I got a value of 0.4 for that part of the equation. I then took our mean value. I'm sorry, I was looking at number 5, but it was already given us sigma, excuse me, and so we just took sigma, going back to number 4, and divided it by the square root of n to get a value of 0.28. I was just trying to make it much more harder than it needed to be. But so then we go and put that value in our correct z equation of x bar minus mu divided by sigma x to get a value of 10.75 minus 10 divided by 0.28 to get a z-cal of 2.65. I apologize again for getting the questions mixed up. But our null hypothesis is going to be that x bar is going to be equal to mu, and that means our alternative hypothesis would be x bar is not equal to mu. Our alpha is 0.05, and we found that Z critical was 1.96, and that is in fact smaller than 2.65, which is our Z calculated score. So in this decision, we are going to reject HO and accept H1. So this is going to mean that the program is producing significantly higher average scores. So definitely needs some correction in the programming. Now we're on to number 5. So it says that in a second execution of the program, X bar is now 9.73. And it says, do the means of the two batches differ significantly? So as I mentioned before, I got a sigma of X bar 1 minus X bar 2 to be 0.4. And I took that and put that in the correct Z equation to get 10.75, which is our mean from the first program round. Subtracting it from 9.73, which is supposed to be the corrected, the correction round, and divided it by 0.4 to get a Z equals 1.02 divided by 0.4 to get a Z cal of 2.55. So the setup is still the same as before. However, we now have, we're trying to figure out if mu1 is equal to mu2. So our alternative hypothesis will be mu1 is not equal to mu2. Our alpha is still 0.05, and we found that Z cal was 2.55, and our Z crit is still 1.96. So in this decision, we will once again reject HO and accept H1. And the English part of it would be that the population average from the first sample is in fact significantly higher than the average population from the second sample taken. So I think there's still some corrections that might need to go on with that computer programming. So I'm just going to go ahead and show you a brief look at what question 4 and 5 is, just so we can clear up any more other confusions and stuff like that. As you can see, it's a bit of a mess, but I did try to highlight it just to make sure that everything was as organized the best it could be. However, we're getting kind of low on time, so for the next few questions, I'll make another YouTube video. So this will be the end of part 1 to the Chapter 8 textbook problems. And I once again apologize for the fact that I had my questions out of order. It's Monday, what can you do? But I hope everything else made sense, and please stay tuned for part 2 of Chapter 8 textbook problems that should hopefully contain 6 through 11 if we have enough time, but some of these questions do take a little bit longer to explain just because there's so many important parts involved. So I thank you for watching, and like I said, stay tuned for part 2. Thanks.